name is Kevin Anderson, and this is my Do Something and Report It project for BB 2201, Renewable Energy and the Environment. And for my project, I am actually breaking water apart into oxygen and hydrogen. So as you can see here, I have a little battery charger, and then in this cake pan I have water, and each clamp from the battery charger is holding a piece of sheet metal just like this, and when I plug this in, a current's going to transfer in between each sheet of metal, and on the positive side bubbles will form of oxygen, and on the negative side bubbles will form of hydrogen. So I have two kind of baby food glass jars above each piece of metal to collect that gas. So I'm going to plug it in. It kind of takes a while here, but I've already been doing it for the last couple of days off and on. So I don't know if you heard that turn on or not, but it kind of makes a little high-pitched ringing sound when it's plugged in. You may be wondering what hydrogen really has to do with renewable energy, and one of the problems with renewable energy is that a lot of it is generated on off-peak load time. So, for example, wind power might be the most efficient at night when it's not really needed. And we don't have a storage system within our grid to store energy for times when it's needed most. It's almost like on the fly. Power plants are either upping their capacity or lowering their capacity. So this could be something they could while they're generating electricity, run that current through water, collect the hydrogen, store it later, and then when the energy is needed, all they have to do is kind of have a combustion chamber for the hydrogen that would either heat up water into steam that spins a turbine, or something like that, kind of like a coal power plant might have, almost most power plants that involve burning something. Right now there's one project in particular that renewable energy, National Renewable Energy Laboratory and XL Energy are teaming together that they actually do this. They have 2 wind turbines and some solar panels, and then they are creating hydrogen to store for later combustion on the site. And they're just kind of doing this as it's just kind of a research stage. It's not really into higher. It doesn't produce that much electricity. So now I'm going to unplug the battery, and I'm going to try to kind of demonstrate here how hydrogen is flammable. I have my lighter here, and I'm going to pull off these glasses. So this one's full of air, and hydrogen is much lighter than air is. So when I pull this out, do it carefully, all the hydrogen should be in the top of this glass. And when I light this, hopefully it should light. If not, that's my fault, and theoretically that should happen. I'm not sure if you guys saw that flame up there a little bit, but it did. I'm using my phone now, so I don't know if it's the best picture. One problem that people might think there is here is that you go through a lot of water. Well, the thing is, when I burnt that, I felt the water drip back in my hand. So when you burn hydrogen, it just turns back into water. So it's kind of just a closed loop cycle, and you can just reuse it. And then the other gas that's formed as oxygen could either be a co-product that's sold to different chemical processing companies that need oxygen, or another idea is potentially you could mix it with the hydrogen and it becomes explosive, similar to gasoline that's used in cars. So it could potentially be used as a fuel for vehicles, but that's not really being looked at right now because that would cause, you would need an overhaul of infrastructure, as transporting a gas around the nation rather than a liquid is different, so you'd have to change pipelines, you'd have to change cars and everything like that. But that's just kind of an idea I have that I think maybe down the line it could be worth looking at. So thanks for your time, and this has been my project.